Good morning, students. How are you? I think all of you well. Today we'll start real numbers part 3 and listen and careful. Good morning, students. How are you? All of you done your homework? Okay. I think all of you done your homework completely. Today we learn about irrational numbers. This is your new topic. What are irrational numbers? All of you know numbers that cannot be expressed in the form p by q, where p and q are integers and q is not equals to 0. Examples: root 2, root 3, root 15, pi, minus root 2 by 3, 0.101110110111110, etc. So irrational number, those numbers who cannot be expressed in the form of p by q. As you know in previous class, today we prove some important theorem which is very valuable for you. Theorem: let p be a prime number and a be a positive integers. If p divides a square, then p divides a. Listen carefully again. This theorem: let p be a prime number and a be a Let p be a prime number and a be a positive integers. If p divides a square, then p divides a. Proof: let the prime factorization of a be as follows: a equals to p1 multiply p2 multiply p3 multiply multiply pn. What is in this equation ? It means there are many numbers up to n terms. So use Pn, where P1, P2, P3, Pn are primes. This is not necessarily distinct. Now, squaring both sides, and you get a square equals to P1 into P2 into P3 P1. Same term, and you get a square equals to P1 square into P2 square into P3 square into Pn square. It is given that P is a prime and it divides a square. From the uniqueness of the fundamental theorem of arithmetic, it follows that the only prime factors of a square are P1, P2, P3 Pn. So P is one of P1, P2, P3 Pn. Since a equals to P1, P2, P3 P1 and P divides a. This is fundamental theorem of arithmetic uniqueness application. It's very simple. In this theorem, you learn that if p square divides a square, p divides a square, then p divides a. Use this theorem and learn some theorems. Next theorem, root 2 is irrational number. Prove that root 2 is irrational number. You know, all of you know that root 2 is irrational, but how can you prove it? By the method of contradiction. We use contradiction method to prove root 2 is irrational. Proof: let root 2 equals to a by b. You know, a by b is a rational number where a and b are co-prime numbers. All of you know what is prime number and co-prime number. So a by b is a rational number. Using cross multiplication method, you find b root 2 equals to a. Again, 2b square equals to a square. B square equals to a square by 2. And clearly this is, you have seen that a square is divisible by 2, and so a is divisible by 2. Let a equals to 2m, another integer. And substituting the value of a equals to 2m in b square equals to a square by 2, we get b square equals to 4m square by 2, b square equals to 2m square, b square by 2 equals to m square, and therefore b square is divisible by 2, and so b is divisible by 2. What you see here, let we assume that root 2 equals to a by b is a real number. It means they are co-prime numbers no more than having factor 1 and itself. But what we observe here, a is also factor 2 and b is also factor 2. It means the factor is more than 2. Therefore, a is divisible by 2, b is divisible by 2. So the option a and b are co-prime is wrong. So what is true? Root 2, hence root 2 cannot be put in the form of a by b. So what is true? Root 2 is irrational number. It is very easy to understand. In this way you can prove another examples. Prove that 6 plus root 2 is irrational numbers. How can you prove? Solutions. Let us assume that 6 plus root 2 is irrational. Then 6 plus root 2 equals to a by b. Root 2 equal to a by b minus 6 by transposing. And root 2 equal to a minus 6b by b. What we observe here? In the RHS, irrational number, and in LHS, rational number. So, our assumption is wrong, because our assumption is 6 plus root 2 is irrational, and here we observe that an irrational number is equal to rational number. This is contradiction. Since a and b are rational numbers, therefore a minus 6b by b is also rational. Thus, in turn implies that root 2 is rational. This is contradiction, as I told you. Therefore, 6 plus root 2 is irrational numbers. So, it is very easy to follow both the important theorem. You can do some more examples in your textbook, in your other books. In the same way, we can prove that root 3 is irrational numbers. Okay, students, you all of you do these examples and exercise questions, and this is the end of part 3, your homework and classwork, example 9, 10, 11. Thank you.